So these are the main area for the research. Suppose if you go for if anybody is in research sections and research, you are doing in research, so it is very easy to implement that one. If you are using the AI and connect with some IoT devices, then you can create so many. That is a patterns you can create it. It is possible. So in this way, then you can choose this research topics in your research areas. Another one, what are that the computing is used in the AI? So it is the so many machine learning algorithms. It's applied into that edge computing and neural networks. So if you are using the natural language processing also, then we can collaborate with that edge AI to convert into that particular one. And deep learning to train the models and accurately perform the computational data. So edge devices is the use for that one. Okay, so we can using the routers and switches and cameras and sensors. So these are the areas we can apply it into the neural network areas or network path defining functions. So in this way, then we can apply for that the edge computing used in AI. Another one, what are the traditional the model? Edge can be used in the traditional model to refer into that run model interfacing based on that edge computing methods. So another one, what are the type of edge computings are there? So we can, in this way, then we can use the edge computing AI applied into that in your structure to find it the best solutions for that in your areas. One is if you are using the sensor edge, then we can using some IoT devices to find the gas leakage, so mileage for that petrol, the car. So in this way, then we can using based on the sensors. So we can find it. Another one, temperature. So the sensor edge, if you are applied for that one, then finding the temperature management and the weather forecast, then you can use it. Another one, it is the second method of edge is it's using the device edges. So the device edges you can apply it for the routers, you can apply it into some areas to find it the traffic signals, and that is the road maps. Then we can using the devices. Another one, the temporal database, that we can use the device edges. Then router edges. So for your path defining, another one in the network area. Then traffic signals, then congestion control, then we can apply it in some network structures that we can using the router edges. Then branch edges, it is the expanding. So we can expanding into that scalable devices. If you are applied the scalable devices is based on the some servers, then we can using the branch edges. And local area network edges is nothing but we can apply it into the centralized servers, centralized network areas, then centralized receivers we have to apply to find it some difficulties in noise or whatever in that one. Then we can using the local area network edge, it is also applied. And enterprise edge, it is based on the business level. Then we can using the enterprise edges. So we can find it the solution based on that business level activities, then selling or anything. So for nowadays we are using that in enterprise edges. So it is one of the best method to use in EDI, that's the edge computing in the scalable methods. Next, the data center edges. If you are connecting with that cloud AI, then we can analyze the using the data center edges, and we can get the resources in the data centers. So we can select the resources, filtering that particular database. So everything it is based on that using the data center edges. Then cloud edge and mobile edge. If you use that cloud edge, it's very nearer cloud AI, then we can get the resources and do the operations. The virtual machines we can create it. Okay, so based on that one, then we can analyze that cloud edge also. So in mobile edge, we can analyze that mobile through the mobile. So what are the applications it's implemented based on the edge computing. Another one that nowadays we are using the Kavalan app, no? So the button is there, then automatically we can shake in that one, that Kavalan, the police, it's having that, the Kavalan security purpose. So that mobile, that method it is implemented into that mobile edges. Okay, so in this way, then we can use the edge computing in several number of types of edges. It's used in that one. So main categories, what the categories based on that one? The proximity. So edge devices are typically located closer to the user at the end of the network. So this is the main method it is applied into that edge computing. So offline operation, it is best in that offline operation, and local processing or centralized processing, it is applied, and it is a main category. Local, it is possible, then we can apply it into that. We can use the particular one in the edge computing in that localized one. And privacy enhancement, then scalable. So scalability and real-time insights, and reduce the bandwidth usage and resilience. So these are the main characteristics of that one. So main thing in this one, it is how the computing, it is the integrate with the edge computing. So AI integrate with the edge computing. So edge computing allows the data to be stored close to the device location. So this is the main method to be applied into that one. And AI algorithm is enable processing right on the network edge with or without an internet connection. So it is possible. Okay. So main thing, that is we can store and we can get the data and it nearer to that particular device locations. Then based on that one, then we can apply the any other machine learning algorithm or deep learning algorithm. It is applied to get the resources. It is within a seconds. So that is the optimized results and higher performance, then we can get it. So in this way, then we can integrate. So this capacity may be the data processing within the milliseconds, and the real-time feedback we can get it in this method. We can apply it into that AI integrated with the edge computing. So how that scalability challenges, in what are the challenges is available, and how we can rectify the challenges, it is based on the artificial intelligence. So first, we can use that the AI systems, it's a handle increasing the amounts of data. So suppose if it is scalable, so we can scale that one, any environment networking structure or data sources, then we can scale it. So we can use that data and user. So and the computational complexity, so everything it will increase. So without compromising the performance. Okay, so we can compromise that performance level, and we can elaborate, we can extend the scalable systems. It is possible. Okay, so it is easy to possible to implement in that edge computing and combined with the artificial intelligence. Okay, so where it is challenges are there. First one, the challenges, it is the centralized processing overloads cloud servers. So that is a overloads in the cloud servers. Then we can use that method, and we can minimize that overload, and we can process. So where it is used and which type of the method we can analyze, then we can using the VMwares. Yeah, cloud servers. If it is the overload, then automatically we can go for the virtual machines applied into that particular servers. Then we can minimize that process, and the overload is minimized. So in this method, in that way, then we can using the edge computing method. it is faster. So already it is there in the cloud servers, then we are using the virtual machine performance. Using the virtual machines, then we can assign that 2 or 3 machines, virtual machines, we can assign that job then to reduce the overloads. It is possible. Then we can compare with that approximate result based on the virtual machines. Then we can implement in the edge computing method, edge AI. So automatically we can get the higher performance results. It is possible in this edge computing method we can apply. So this is one research area. Then we can compare with that cloud AI and compare with that edge computing AI, how it will interact and how it will, the comparison between the performance analysis of both the different method of AI. It is possible. Then we can do that. So another method, it is another that the challenge is it can using the massive data transfer. The data transfer cost and network congestions, it is the another the challenge area in that scalability. So we can scale the data, the method, infrastructure method and network method, then easily find the best path to transfer the data. Okay, so it is if it is a network congestion, so automatically we can choose the best methods of network path to avoid the congestion and to transfer the data, and it is easily. So if you are scaled, if you are applied into the edge AI method. Another the method is a real-time applications. So that is main thing. It is the instant inferences. So suppose if you are combined with the cloud, so you can get the data from the cloud. So in the time, so that is the some delays will occur. So if you want to avoid that particular one, the delays and interruptions, then we can apply the edge AI. So it is possible. So these are the main challenging areas is there. So another one, it is a scalable system. It is the main thing. This is the research areas are applied and easy to find it the research findings. Next, it is the AI scalability a challenge. In this AI scalability a challenge, what are the challenges are there? The training the complex AI model, it requires the massive computational power. So training complex, we can create the AI model using the challengeable one. It requires the massive computational powers. Real-time processing and interference is the often required the local level. So real-time processing for interference is required at local level, and centralized cloud models face bottleneck with the latency and bandwidth for large scale and distributed deployment. So these are the main challenges. Already we discussed about that one. So how the processing and the local level and centralized clouds, the bottleneck will occur, how we can rectify it. So what is that latency? Then how we can using the minimum latency and how we can be using the minimum bandwidth. So these are the scaled process. So we can using in that edge computing methods. So the importance of scalability of edge computing is, so main important is we can using the large concerns regarding the AI architecture relate to the scalability, because the capacity of the scaled up and down workload or user traffic or to incorporate innovations is the measures of flexibility with the sorts of the systems. So we can scaled. We can scaled automatically, then we can you applied into that particular one. So as an organization extend out more form factor devices and services that inhibit the edge, those business need architecture that can scale up, down or without much cost in speed and accuracy or security. So in the business levels, then we can apply it in that architecture. We can scale it. The cost of the performance in the particular one, it is less, and accuracy, high accuracy, and it's give the security process also. So the scale-up component on the edge AI architecture, how that AI architecture it should be defined. Then what are the key concept of the AI devices? The key concept of this one, it is the computational power. So next, storage and connectivity. This is the three things we need to implement these each and every component. It is based on that architecture. Okay, if you are scaled, if you use that edge computing, so edge devices. So the network edges refers to the system involved in the creation, collection, analysis, and control of the data, or situated the boundaries of the network. So we can fix that boundary. So in that boundary, it's very closer boundaries, then we can use it. So first we have to fix that boundary. Another one, so that the analysis and control the data, it is very easier to find it, these things. So if you are applied into that sensors or cameras, or it is using the cars and industrial machines, so it is possible to use that one. Okay, what are the main categories for this? If you want to scale the component, automatically the characteristics, it should be satisfied, no? So that is the computational power. So the based on the computational power, which type of algorithm we can apply. So many AI algorithms are there. So we can apply that AI algorithm, set the constraint that at least most of the computations must be done by the device in the visionaries. Next, storage. So storage, in which data to be stored, and how the data, how much data. So the detailed data to be stored in that particular edge devices, and it will have that enough storage it is there, then we can fix it that based on the boundary, then we can fix it the storage one. Another one, which parameters then the data to be taken from that data, taken from that particular one. So we can analyze that. Another one, type of connectivity. Which type of connectivity then we can use it? It is a WAN type connectivity, means then which include the Wi-Fi or cellular connectivity, and what record access the devices or cloud services. So main thing in the edge AI, if so many there is a case studies are available. So you can see that case studies. So the cloud AI and edge computing, it is compared. So the so many cloud servers are used nearer to use into that edge computing networking environment. Then in this way, so what are the method then we can applied and scaled that particular one. Okay, so this is the gateways. So this is the gateway connectivity. It is based on that one, that is a three layers. You can see that the three ways that we can divide it into that architecture. So this is the architecture of that particular one. We can apply it into the gateways. So in that first one, you can see that it is the sensors is applied, and which type of sensors is the button sensors is there, PIR sensors is there, it is receivers, it is used for that one. At the door and window sensors are there, it is a touch sensors are there. Then it is the temporary humidity sensors is there. So in this way, that's the gateway, it should be applied edge, and the gateway is based on the modems. So it is received and it can applied into that the data. You can nearer data to be stored or nearer data to be fetched, or whatever that resources, it should be nearer into that cloud. So this is the three architecture, the three layers, it should be applied into this edge architecture. So it is the main gateway method it should be used. SenStack, it's used for this type of gateways connectivity to getting the implementing the edge computing. It is one case study, and I saw that one. So in this gateways level, that is these centralized devices between the edges devices and cloud and centralized data centers, we can use it. Then we can implement the centralized data centers, it will apply. Another one, edge devices to gather the information from the edge devices, from the computations and transmit the data and analysis the data, it finding the analysis. So it will applied into that particular one. Another one, what are the functions? The gateways is applied. So what are the functions it should be applied for the gateway? So data aggregation is possible, and protocol translations and security management. So the functions is, first is it is a data aggregation. So data aggregation means it is nothing but to collect the informations and combine all received data from the several sources. Okay, so in this way, then we can the edge gateways to gather the data. Then applied the protocol translations, it requires the support of various communication protocols to make it compatible. So creating it depends upon that services, then we can create the protocol based on that protocol translations. It is using the edge gateways. Another method, the third one, it is the function is security management. So the existence and of the proper measures intending to prevent the act of the data sharding during the transmissions. So the data sharding is the main concept. It should be applied into that security management to secure the data is in this main function for the edge gateways. So these are the main method if you are using the edge gateways. Next, the AI models and frameworks. So what are the frameworks that applied into that AI model using in the edge net architecture? So in this scalable edge AI architecture, try to use the machine learning model for edge computing, which are optimized for the edge conditions. It applied that edge conditions to get the optimized results, so that the method and the infrastructure, the architecture to be applied and to implement the some machine learning models. So the models record are efficient, easily portable, and it can perform the inferences and high-speed edge devices to be applied into that. So what are the existing AI frameworks? The edge are TransferFlow Lite and PyTorch Mobile and Onyx. So it offers the tools, some optimization tools we can apply and find it the optimized tools, the performance will be get it. And another one, we can scale that solution also, then we can use deployed some different type of tools also. So in this way, that the framework to be construct and the architecture to be used, and main thing that the AI model it applied in the edge computing, everyone can create that own method, the architecture method to implement and to get that high performance results. So what are the main role for that using the edge computing in artificial intelligence scalability? So reduce the latency. So already we saw that one. Main thing, it is a reduce the latency for the real-time applications. So how and which way, then we can see that the processing data is in locally, and edge computing enables the instant decision makings, then time sensitive applications like autonomous vehicle and factory automations. So the automatic vehicle, no, that without the driver, then we can run that vehicle. So it is applied for the edge computing method and implementing with the some process. So another one, to eliminate the round trip delay of sending the data to the cloud and waiting for the response. So main thing in this we can analyze based on the cloud server processing, then cloud job allocations. So these are the main goal to easily to get the higher performance results. Another one, optimized bandwidth use. The process and filters the raw data locally, transmitting only necessary insight to the clouds, and significant reduce the data transfer costs and network congestions, and especially large data sets like the high resolutions videos. So we'll created the data set based on the data sets, then to avoid that network congestions and transfer cost, data transfer cost, it's everything, it should be reduced if you are applied into that methods. So next, another the characteristics or another method, it is the enhance the data privacy and security. So sensitive data can processed and stored locally, minimize its exposure to the public network. So in that edge computing method, automatically then we can using these very nearer devices, then we can store that particular data and minimize the exposure to the public networks. So next one, the crucial for applications in the healthcare, surveillance cameras and surveillance receivers. So in this way, then we can apply it into that one, and other regulated industries. So industries some to create the warnings or some messages, immediate messages, and through that sensors, then we can enhance the data privacy and security methods and increasing the system's reliability. So edge devices can continue to operate and make AI-driven decisions even with the intermittent or non-connectivity to the clouds. So in this increased system reliability, and we can go for the use of cases. What are the use cases of AI? It is a smart cities and applied in that edge computing. Smart cities where it is applied, it is for the traffic flow. Another one, optimization for the bus frequency and improving the public safety. So that is the governance. It is one of that important one. Another, what are the public safety by analyzing the data from the street side cameras, then using the sensors in the real time methods. So it is applied into that based on that particular use of the edge computing. Next, it is applied and it is used in the manufacturing. So predictivity maintenance and quality control by analyzing sensor data from assembly lines, robots, and detect the anomalies instantly. So what are that anomalies is detected, so we can easily find. It is one type of manufacturing, means automatically. One example, it is the leakage of gases. No? If industry, the leakage of gases, then we can apply it for that one. Immediately, it will detect and to get the alarm to that particular persons or particular companies. Then the next method, it is called, it is the healthcare. It is implemented into the healthcare. So the healthcare, it is a remote patient monitoring with wearable devices to analyze the health data and immediate alerts for the critical events. So in this way, then healthcare sensor data is applied, and retail in the stores, in the warehouses. So then we analyze that customer behaviors and inventory in real time, personalized shopping experience. So in the feedback we can create it. So many related to that shops, then we can analyze the use of the artificial intelligence in that one. So another one, architecture overview for that edge computing. How, in which, then we'll go for that. We can see that So what are the ways the devices to be implemented? How we can construct the user, the researcher, how we can construct that architecture based on that one. So that is main thing. That is a three different layers we can construct. One is the device layer, next one edge layer, and third one it is a cloud layer. So device layer, so what are the devices we are using to analyzing? So we are applied into our research. So it is possible if you are using the device layer. So suppose we are using the IoT sensors, or it is a cameras, or it is through the mobile devices. So any one kind of devices we can install into that device layer. The second layer of the architecture is it is the edge layer, the local servers and gateways performing the inferences. So main thing, the edge layer it is nothing but which is the service we are applied. It is a local servers, or it is centralized servers, or it is having the gateways. So in this way then we can construct or we can derive into that edge layer. The third part of the layer is it is a cloud layer. So that layer it should be model training or updates and analytics. So any kind of one then we can analyze to implement into that there. So main architecture it consider in these three concepts. Okay. So this is that main layers. It's a layer. The layer one, it is a cloud layer, the modeling, training, and centralized control, data storage, analytics, everything. It should be done into that one based on that cloud layer. So we can apply it. The edge layer is it's a local servers, real-time inferences, caching, filtering, and pre-processing. So based on that one, then we can using the edge layer. And device layer, it is using the devices to implement with that edge layer. Okay, so it is controlled with that edge layer, and you can get the data through the device layer to that edge layer, and then you can get the data from the edge layer and store the particular data into that cloud layer also. So this is the main architecture for that edge computing artificial intelligence is implemented. So this is the happens the typical edge architecture. See that the cloud and data center is in that right side. So the left, all the devices it should be there. So edge devices. So through the edge devices to implement the edge devices, AI devices, and it like a camera, robot, or sensors. So then we can apply any one kind of applications and taken the data, taken the value from that cloud and data centers. Okay, so in that middle, then what are the real-time interferences to be there? That is called the edge computers. So in this implemented the edge computers to reduce the bandwidth and faster decisions. So based on that in the edge center. So this is the three architecture diagram to be implemented into your systems. It's based on your research methods. Then you can implement and you can get the results. So edge and AI intelligence, it is model to be deployed. So we can create the models, we can implement that model, it is efficiency. So enables autonomous decision makings without the cloud dependency, it is possible. And scale by, if you are scaled, it is based on the edge devices. So if you are creating so many type of edge devices to communicate with that particular AI, then we can integrate the particular one to get the scaled one. Okay. What are the technologies? How it will enable in the edge AI? So the TinyML, it is the lightweight models to be ML models to be using for that small devices, and 5G network connections. The 5G network connections automatically it is used into the real-time networking and real-time high-speed connectivity. Then we can apply it for that one. Another one, containerizations. It's the Docker. Then Kubernetes for a distributed artificial workload. So main thing, if you are having the workload, it is the overload for that one, then easy to analyze, easy to distribute that artificial intelligence of edge computing, easy to distribute that workload into that number of servers. It is possible. It is easy. It is the method to be applied. It is one. Another one, edge AI chips. It is the using for that Google Coral, Intel Movidas, and then NVIDIA Jetson. So it is the some AI edge chips to be implemented into your servers to do that particular operations. Based on that one, then how that servers to be used and how it will implement, what are the challenges to be there, then what are the limitations. So in this one, if you apply the limited computational power on the edge devices and model updates and synchronous complexity, security vulnerability in distributed environment, and managing the heterogeneous hardware. Okay, so these are the main challenges and limitations. So we can apply it to rectify it easily in that edge computing if you are applied into your particular architecture devices. So what are the future trend? So in that future trend, federal learning on privacy, specific model training, edge cloud collaborations for the hybrid AI, and energy efficient AI models, and expansion of 6G enabled intelligent edge systems. So these are the future trends. Nowadays, the collaboration with the AI and the hybrid, using the hybrid AI to collaborate with the edge computing is nowadays the very big area to be, improving. Nowadays, it will go for that research one. And if you are using the energy efficiency a model also, we can create it. It is possible to find it. So these are the future, the AI edge computing applied in methods. Then scalable edge. What is the growth? If you are scaled that edge AI, so what that growth for that one? It is customized. So we can, any user can customize to that particular one and easily to create that structures, and now leading the main that the breakthrough the industries in not in centralized, it is in the distributed level also, then we can that is a customized. Another one, how that edge computing architecture it is applied, data processing, it is applied, decision making. So in the real-time applications we can apply it easily, and optimized resource finding and resource usage for the data and processing. So these are the main scalable the growth it is there. There are the main solutions of that particular one. It is the large amount of data to be analyzed and processed is possible. So many applications is there. Then industry level, it is the higher level, the edge applications are applied. Healthcare and smart cities. One another one, the AI-based edge computing platforms are also highly scalable. It is easy to scale and it is a highly scalable one. Artificial intelligence based edge. It means the organization can easily grow its IoT environment with the simple additions of more nodes. We can expand, so easily expand that particular organization in using some devices, and we can expand it. It is easy. So next one, flexibility also. Using the flexibility, new machines or sensors can easily incorporated into the existing edge computing model. Suppose the older model is there, then we can easily incorporate with that one. So allowing the dynamism in the industrial systems also. So in this way, the scaled of that role of that particular edge computing, it is the very high performance in this nowadays. It is possible. So based on that, in my talk, based on that edge computing, so how it will scaled and why that edge it should be implemented into that combined with that AI. So the edge computing is the nowadays it is the very critical enable for building the scalable AI systems by addressing the limitations and purely cloud-based approaches. So already so many projects are there. It is based on the cloud AI. So in that one it has so many difficulties, so many that limitation it should be there, so we can address these limitations, so we can avoid the particular one to increase that data processing, increase that scalable one, and increase the bandwidth is less bandwidth, then we can using reducing the latency and conversing the bandwidth. Another one, security, improve the security. So in this way, the edge artificial intelligence is applied. Another one, we can easily hybrid in that one with the cloud structure. So edge computing is hybrid with the cloud architecture and more to provide the most robust and scalable solutions for the modern AI applications. So next one, it is a continued evaluation of edge computing alongside technologies like 5G will drive the next wave of AI innovations. So this is the method in this edge computing artificial intelligence method to be applied into the new era. So new method, it is very easy to adopt into that technology and in the coming eras also. So this is my talk, and I think I hope I'll cleared about the structure of how the edge computing it should be implemented within environment, within centralized or it is the decentralized environment, how it will implement into your research methods. So I think it is cleared. Okay. So okay, any other queries related to that one, madam? Thank you for.
Thank you so much, ma'am. Does anyone have any queries? Does anyone have queries? Okay, ma'am. May I conclude the session, ma'am?
Okay, okay, ma'am. If you have, okay, ma'am. Okay.
Okay, okay. Thank you, ma'am. Good evening, everyone. As we conclude our 5-day faculty development program on building smart system, AI, edge computing, and ethical design, it is my pleasure to extend a heartfelt thanks to all who contributed to its success. First of all, we sincerely thank today's spokesperson, Dr. Booba Ma'am, for her insightful and engaging session. We also extend our gratitude to the resource persons. Over the past 5 days, Dr. Soumya Ma'am, Dr. Subhashri Ma'am, Jagadish Sir, and Dharmarajan Sir, your expertise, guidance, and dedication have made this program highly effective. A special thanks to all the participants for your active involvement, enthusiasm, and thoughtful interactions, which truly made this session lively and meaningful. Finally, we acknowledge the organizing team for their relentless efforts in ensuring the smooth conduct of this FDP. Thank you all for being part of our journey. We look forward to meeting you in future programs. Thank you all, and have a wonderful evening. Thank you, ma'am.
Thank you, ma'am. Thank you for organization also. So SKRGC Academy, I heart heartful thanks to sir also. Okay, it's a very good
Thank you, ma'am.
opportunity for 2 times I received it. Thank you, ma'am. Convey my regards to sir also.
Yeah, ma'am. Surely, ma'am. Thank
Yeah,
you so much, ma'am.
thank you for.